handouts. Arena, you're close by. Did I name two functions at the top of the page there, like an f of x or g of x? Okay, name the f of x function for me.
2x squared plus 3x minus 8.
Okay, then wait, 2x squared plus 3x
3x minus 8.
minus 8. Okay, and what did I get for the g of x?
X plus 1.
X plus 1.
Yes.
Wow. And question number 1 was, I will lead you into this. More than likely on the handout, I asked you to take those two functions and do merely this to it, which is a giveaway. Show this with respect to x. In other words, add the two functions together. All we want is take that function she gave me, 2x squared plus 3x minus 8, and add to it x plus 1, the second function. That's all it means, add the two functions together. In this case, I can simplify, combine like terms, and it looks like 2x squared plus, what is that, 4x? I guess subtract 7, I did it quickly, and there's your answer. You're finished. So can I take two functions and do something with both them, like adding them? That's all you're doing. Number 2, more than likely on that handout, I was probably asking for the difference of the two functions. Easily done. That 2x squared plus 3x, subtract 8. And this time we want to subtract from it the one she gave me, x plus 1. Right, because this is basic algebra. Now if I do a few side changes and so forth on the end there, I'm going to go ahead and place the answer here, guys. This is 2x squared, do not make a mistake though. Is it plus 2x minus 9, is it? I'll look at that quickly. See if you guys agree. Or is it minus 9? Yeah, it was, wasn't it? Is that true? Yes, no? Yeah, but that's nothing hard. Number 3, another arithmetic operation. Just doing arithmetic here. They may ask you to form the product of the two. And the product of the two would be merely you doing this, 2x squared plus 3x minus 8. I know if I multiply this out for you, I'm going to set it up for you, times x plus 1. That's all they want. And then, of course, you would have to expand that out, which is easily done. Number 4, quotient. They ask for f of x over g of x, no problem, no issue. That would be 2x squared plus 3x minus 8 over x plus 1. Now maybe, that's exactly what they wanted. They wanted to add, difference, product, quotient. This might simplify. And you've seen some of these before, they do simplify. You might be able to factor the top. I don't know yet, I haven't tried it. You may be able to factor that top, and maybe that x plus 1 will drop out. And maybe simplify it, reduce it down. Guys, does anyone think they will factor, just out of curiosity, 2x squared plus 3x minus 8? You think it might? If not, we'll just leave it. Anyone think that numerator will factor? And in fact, if it does factor, will the x plus 1 maybe cancel out and make it a nice answer for us? Sometimes that happens, sometimes not. I'm looking at it right quickly. I don't think it's going to factor, is it? Anyone tried to factor? If not, we'll leave it. Okay? You said Professor, my goodness, that's middle school. Now, seems like though, the next one, number 5, in blue here, is asked me to do something else with the function. Not add, subtract, multiply, divide. That's too elementary. And they're using a symbol to indicate what they want. Not a plus sign, not a minus sign, not a product. So say now find this, f, little circle, g of x. Not a plus, not a minus, not a quotient. Now, those of us who have had some math before, and we've all had math before, does anyone recall what the little circle in between those two functions now would be asking me to do?
Both.
Do it again.
Both.
It is, FOG followed, but what does it mean? There's a word there.
We
They
need to
use-
find first the J of X.
Yeah, hang on though, hang on. Let's get some vocabulary out of the way. If I did this, I'm finding the sum. Here I found the difference. I'm using some words. Here I was finding the product, and here I was finding the quotient. What am I finding here? I need a vocabulary word. Who remembers?
Function.
No. Oh, no one remembers what I'm finding there. I'll find it. But what is it? Sum, difference, product, quotient. What's the term, vocabulary that goes along with this one? Now, you've forgotten. They're asking you now to find this. Find the composite. Find the composite between those two functions. Now, here's what you do recall. Guarantee you. How do you find it? You don't add, you don't subtract, you don't divide like I did the others. They're saying, no, the definition now, you find this. You find f of g of x. F of g of x. Which means you're going to take g of x and go back to my original function and replace it. And here it goes. Rena, since you're close by, did I give a new function to work with for the composites, or did I stick with the same function? I stuck with the same function? I stuck with this. Here. Okay, let's do it then. So stick with the same function. Let's take that g of x and we'll go back to my f and do a substitution. I got to write like this. Means 2 times, back in the f, we're going to put the g. And the g was, in this case, x plus 1. She says that's being squared. And then plus 3 times, again, here goes. We're putting in g, x plus 1. Problem. Close that up. Subtract 8. Go to my f function and replace all those x's by g of x. Replacing one function into another function. Now you know and I know you need to clean that up. I'm not going to clean it up for you. You can multiply it out, expand it out, combine like terms, but that's exactly what they mean for you to do. You need to clean that up. F circle G. Arena, did I ask next? What did I ask next?
G circle F.
Yeah, now maybe turn around. Put this in blue here since we're doing something a little different. He says this time it's G circle F, a composite they call it. And by definition, it now means if it's written in that order, you're finding G of f of x. These are easy. And the way it's written, this says do what with what? You're placing which one into which? Read this
Place
one.
F of X.
Yeah, you're placing F into G, aren't you? So here's G, so let's go down to the G and put the F. That's going to look strange there. If I go down to the G and replace X by the F, you're going to end up with, and see if you guys will agree, looks like 2x squared plus 3x subtract 8. That, then plus 1 on the end. Right here. Easily done here. I'll go ahead and simplify this one for you. This is 2x squared plus 3x. I think it's minus 7, isn't it? Done. My goodness, Professor, give me lots of these on the exam. Give me tons of these on the exam. What's going to be so hard about this? You ever seen the other shit? It's a little harder. Number 7, Rena, did that? I asked you to do another one.
F of F.
F composed with itself, or composite, which by definition means this: f of x. Translated, you're placing f right back into itself. What's it going to look like? Here we go. 2 times, and do not let me make a mistake here. I'm taking f right back into itself, so I'm replacing the x's with the original function. Okay, so that first one's going to be 2x squared plus 3x. What was it? two x squared plus three x minus 8. That's gonna look a little strange here, guys. That's being squared plus 3 times 2x squared plus 3x minus 8. And of course, minus 8 down here. Let me see if I can look at it. Do you guys agree? Is that the way this looks if I take it right back into itself?
Yes.
Yes or no?
Yes.
My head's nodding yes, yes, yes. Now, I'm not gonna clean that up. If I ask you to clean it up on the test or a quiz, you gotta clean that up.
We'll let you-
Okay, I'm just leave it like that. We agree with that so far? And the last one was?
G of G.
G was G. Easily done. Their definition is written like this: G of X. Which says now place G back into itself. Thank goodness G is not too bad of a function. Place it back into itself, guys. Please tell me, does that mean it now looks like placing it back into itself? Does that mean x plus 1 plus 1? Right here. Yes or no? And therefore this is easily simplified. It's x plus 2. And those are my composites. Easy? Of course it's easy. I don't see how students go wrong just on the simple composite. You want to place them one into another, one into another. Maybe simplifying you might mess up, but one into the other, easily done. Now what might be a little bit more difficult is, I think, the next part. Arena, are they asking me on the next part to do what with it?
F, G.
Is it different directions? Or same direction, but different functions, different functions? Okay, here we go. Part 2. Read those two functions for me.
F O G.
Oh, wait, I thought the function was f of x is what?
Is it? Oh, I took version number 5 to find the minus.
Oh, no, so you tell me I wasn't quite finished with this one. Okay, number 9 then, let's go to it. Number 9 was asking me to do what?
F
G?
O G
F of G, okay.
minus.
And a minus 2?
No, I'm fine minus. Oh, minus.
Right here.
Yes.
And a negative 2. Like this?
Yes.
Okay. And when I do that, that's even easier. It means this, in terms of a composite, it means take f of g of negative 2. Now this one I can calculate and get a number, since she gave me a number to work with. Now guys, g of a negative 2 says, please go back to this g function. Replace x by a negative 2. No problem. Negative 2 plus 1 gives me a what? Negative 1. So inside there's negative 1, so this is f of a negative 1. And then let's say let's go back now to my f function, do a replacement with that negative 1, and write this as 2 times negative 1 squared plus 3 times negative 1, subtract 8. Make sure I put that in there correctly. I'll go ahead and calculate this one for you. It's not too bad here. Looks like we'll end up with 2 minus 3 minus 8, I think. And what was that all together?
Einstein.
2, was it 2 minus 3 minus 8, what is that, negative 9? All together? Check my arithmetic there. It's a Friday. Is that correct? And now I'll give you another one to practice with a number. Okay, Arena, what was finally number 10?
G of G.
G with G.
Of A plus 4.
Oh, wait, what now?
A plus 4.
A plus 4.
Yes.
like this. I'm doing. It means this, the g of a plus 4. Inside here, it says, please go to my g function, that I have over here again, replace, substitute x with a plus, was it 4? Yeah, a plus 4. So this becomes a plus 4 plus 1, doesn't it, guys? Which is going ahead and call it what? A plus 5. So this becomes g of, inside here is a plus 5. Now what does that mean to do now to finish up? Take it right back to the g function and do it again. This time replace x by what? A plus 5? Yes, no? So a plus 5 plus 1 gives me a final answer of how much? A plus 6. Figure it out. Now, I think I'm ready for the more interesting ones coming up with the square root. Right? Marina, is that coming up now with the square roots involved? Yeah, so I'm asking a little bit more to it. These are the baby problems. These are the feel-good problems. And all of a sudden you run into something, oh, am I feeling so good now? I'm going to see more of these as we go through this here. Okay, Marina, guys, let me erase this. Over here on the side, this is, I think, sort of straightforward. Part 2, tell me this, to close this down, what did I give for the f and g on the next one?
F of x equals square of x.
Wait, square root of,
X.
how much?
Just x.
Just x,
Yes, just x.
inside,
Yes.
okay. And what else did I give?
G of x equals square root 2 minus x.
2 minus x.
Yes.
Oh, this is going to be interesting. Now, underneath there, what did I ask you to do?
Find f of g.
Hang on now, find this with respect to x. And we've already seen the definition here. That means f of g of x, a composite. What it means. Do the same thing you did over here. It may not be quite as easy. You're placing this. Take what she gave me. This is square root 2 subtract x. You're supposed to take f of that. Now this is going to get interesting. I'm supposed to take that blue into the f and replace. Now, you're talking about looking strange. When I take that into the f, it's going to be square root of, see if you guys will agree, it'll be Blackboard first. Square root of, does it now look like, if you will agree, does it look like that? I'd give you credit for that. Does anyone see another way that maybe you could express that answer? I've got a square root underneath the square root. Is there another way to express it? Maybe you have this in the textbook and you check your answer in the back and say, Professor, I missed it.
You can put to 1/2.
Here we go, say again.
Or, I don't know, just 1/2.
Okay, you're saying that in the black, all that could be expressed as something being raised to the 1/2.
Yes.
The blue, same thing, it's being raised to the 1/2. So he's telling me, Professor, it really means 2 subtract x raised to the 1/2 inside there is now being raised also to the 1/2 on the outside.
Yes.
Which now tells me this could be expressed as,
1/4.
absolutely, which means 4th root of 2 subtract x. We're going to put this form, 4th root 2 subtract x. By the way, I'm about to finish this up. That first section of chapter 4 is going to be fairly brief for us. Now, Irina, did I ask something in addition besides just the answers?
And the domain
Oh, wow.
f of g.
F with G like this.
Yes.
Now they want to know what is the domain on this answer. Now you have some domains on the exam tonight. So how would you find the domain of this answer with the fourth root of 2 subtract x? You guys who were with me at 11:30 should know what I'm talking about here. Now, they'll be all real numbers.
2 minus.
Yeah, there's 2 subtract x underneath here. Must be what for that fourth root, square root, sixth root to make sense.
More or equal.
There you go. So 2 subtract x must be greater than or equal to 0. Now to solve this, easily done. You have some of these on the exam tonight. X is less than or equal to, looks like a 2 if I did that correctly. And I'll reverse my symbol. Is that true, guys? So my domain here is negative infinity up to 2 bracket. That's my domain on that fourth root answer. Now, I'm going to get a little trickier as we move along. Here's what the next one is. Hang on a second. I'm ready here. Okay, Marina, what they asked me to find, I got the one out of the way. What's the next one to find? G circle F. Hang on now. So you know it means this. Which means my f of x, she gave me f of x to be this. And I'm supposed to take g of, on the outside, g of that. That's what it means. That means let's go to my g function and do a replacement. If I go to my g function, right here it is, and replace with that square root x, can anyone tell me what that strange answer may look like? Go to the G and do your business there. What it look like? Andrew?
Square root 2 minus square root x.
Absolutely. Absolutely. That's the answer. Now here's the issue. I failed to ask for the domain. There's the answer. The domain on this composite. Oh, we got issues. We got issues. Someone help me out with the issues. Philip, go for it.
I just had a question.
Oh, we got a question.
Could you simplify the 2 minus square root of x?
Now what are you gonna do?
Could you turn it into square root of 2 minus
I knew you were
fourth
gonna
root of
say
x?
I knew you were gonna say that. You cannot. And I'll show you why. I'm glad you asked. He's saying, Professor, could I write like this, guys? That's why. Tonight, my class. Could I rewrite this as, Philip, I think you said this minus probably this, or something like this. You want to actually split it up and take a square root of each one of those. No way. I'll show you why. Subtract 16. That's hang on. Okay, 25 subtract 16, we know is what, 9? And square root 9, the answer is 3. If I do what he suggested over there, say, Professor, why not do it like this? I think that's what we need to do. Will you sort of think like that? Now I got an answer of what? 5 subtract 4, the answer is 1. It's not 1. So you cannot split those up like that. I'm glad you asked. Now I've got to leave it in that form. That's the answer. Now, question is, domain. Can anyone get me a star? Because it's going to be a string here. I now have the answer, but I now need to know what's allowed, or what am I allowed to replace x with.
All real.
That part underneath the square root? I've got 2 square roots.
Yeah, but x, isn't it all real?
No, hold on, whoa. If you say all real real numbers, I can't replace x by a -4. I can't do a square root on -4.
Exactly.
So if something's going on here, you're going to help me out and set this up, and then we'll look at it.
Bracket 0 to.
Oh, you already got the answer. Hang on. What'd you do first?
Well, since the first, square root of x can't be less than 0,
So what'd you do?
it start at 0 and then find, you just define a number that would make.
Okay. Because I'm just trying to find them. Tell me the setup. I bet you probably have the answer. But show me the setup. What's going on here? Yes.
2 minus square root of
Hang
x
on. This.
has to be greater than or equal to 0.
Beautiful. Hang on now. That's beautiful thought. Right there you go. That's gonna be true. That's going to solve for x if I can. I think many students would say, well, Professor, I can solve it if I did this, and then move the 2 over. Make it what, -2? Then divide or multiply by a negative, you get rid of that negative there, but reverse what? Reverse the symbol? So we have square root x is what? Less than or equal to what? 2? And then do what? Right, square both sides. You end up x is less or equal to what? 4. Right? Now, please tell me. Are we now telling me that the domain is x is less than or equal to 4? Are we saying in interval notation it looks like that? Wait, hang on a second. Are we saying that based on what was just given to me? So my domain is anything up to 4. Should work in that answer. And I agree 100% with what we've done. Guys, I'm gonna choose a number right at random here. Negative infinity up to 4. Please tell me. I think I used -4 last time. Would -4 be included in this answer? Is -4 inside this interval? Don't scare me. This is a Friday. Is -4 a number inside this interval if I wish to use it? This is negative infinity all the way up to +4. That takes care of all the negative numbers. And we said earlier what? I can't use -4 at random. I tried -4. You can't do a square root of -4. So my domain is not finished. I got a good start, but it's more than just that. Can anyone else tell me something else that bothers me here that I better take consideration of to get the complete domain? Andrew, go for it.
Do you set it to 2 plus square root of x?
No, something else. I see what you're looking at. Something else is staring at you and says, you better look at me, you better look at me, there's something else going on with me. What is that? This right here. Does that itself have a restriction? Even that, to make sense, must that be this? Now you gotta put both of them together and get a complete domain. So I gotta use what was given here, and I gotta use what's given here. Now can anyone put these two together and write a complete domain for me?
From 0 to
Bracket 0 up to, what was it, 4? Bracket, you get outside that interval, we got issues. There's my domain on that composite. 0 up to 4, not negative infinity up to 4. There was another added restriction there. I thought I saw a hand going up.
I had a question, but I figured it out.
Okay. You guys agree? So if I stick with that domain, it should work. Okay, number 3, Rena, what were they asking next?
G O G.
G with G, hang on. We know for a composite means this. Let's go ahead and find the composite. Placing G back into itself. Well, G was this. Well, it looks strange. Gotta place this back into itself. You guys, if I do, please tell me I get square root of 2 minus, make sure I copy this down correctly. Is it that? 2 minus that. Yes or no, guys? Is it? So that's the answer. Now, usually to find the composite, composite itself's not too bad. It's that domain. I think most of my students can place a function into a function. That's not too bad here. But the domain here, guys, that's the domain, function. Now I need the domain on this G with G. Oh boy, we've got big issues here with this one.
So first of all, we can do 2 minus square root of 2 minus x, and then we can do square root of 2 minus x more equals 0.
Thank you, thank you, thank you. First, he's telling me, Professor, all that is underneath the large square root must be always this. All that underneath the square root, he's telling me that. Now I gotta solve this, and guys, you gotta be careful, you got negative this. Greater than or equal to, let's move that 2 over, make it a negative 2. Just doing some algebra here, arithmetic really. Divide by a negative, be careful, reverse your symbol. Becomes less than or equal to 2, that's division or multiplication by a negative. And then I think most students at this point would tell me, if you want to go ahead and solve it, Professor, do what? Square both sides. I need to square both sides here. If I do, we'll end up with 2 subtract x is less than or equal to 4. Guys, be careful. This is negative x is less than or equal to, this is crazy, a 2. Multiply by a negative, divide by a negative, reverse your symbol. Now, I mean, I did that one quickly. I think the final result there, if there's no mistake, is that.
Yes. And then you have to
Hang on. So x must be greater or equal to a negative 2 at this point. But he's telling me, Professor, be careful. There's also a restriction on this. Inside there. The other square root. And to find it, you place it on the side here, guys. That 2 subtract x must be what? Greater or equal to 0. This one's easily done compared to the last one. Divide or multiply by a negative, reverse my symbol. And please tell me, do I end up with that? Yes or no? Now, what's my complete domain putting both together for this composite? The domain is what?
bracket minus 2,
Bracket negative 2,
2,
up to 2, bracket. Wow, wow, wow. This scares me. It's not the composite that scares me, it's that domain that scares me. Now, if I were you, I'm gonna just randomly check this before I leave it. I'm saying if you get outside this, a number outside this, and you go back and do this business, you're gonna have issues. So let me get outside and see what happens. I'm gonna try 3. 3 shouldn't work. 3's outside. What happens? If I go back and put a 3 in, well, here's what happens. I get 2 subtract 3, that's a negative 1. I can't do a square root on a negative 1 for a real number. So they're saying if you want to make it real, you gotta stay here. Everyone agree? Gee, all over the board here. Was that the last one or is it something else? That's the last one. That's 4.1's finished. Section 4.1 is finished. Yes.
If one of the x's was squared underneath and then you plugged in like g of x into the x, would it cancel out? Like the square root?
Oh, you mean, yes, the square root would drop out.
Yeah.
It would, if you square it. Absolutely. Guys, anything else on this? Okay, I'm moving into now, Arena, you're with me. 4.2 is coming up next?
There's another third.
Oh, I thought you were finished with it. We're not finished? Another composite?
Yes.
Come on, what is? I can squeeze it here on the side here. Okay, name that for me.
It's given f of x equals 2x plus 1
2x plus 1.
divided by x minus 1.
Uh-huh.
X is not x plus 1.
Okay.
G of x equals x plus 1
Whoa.
divided by x minus
together here. So she's giving me two functions with some restrictions, x can't be 1, x can't be 2. I have all that copied out correct. For goodness sakes, what did I ask you to find?
First f of g.
F circle G. Now I'm thinking, why on earth did I place that on that handout? This. She said, Professor, asked you to find this, composite. Who's gonna see that? Same routine, gotta get some strange functions to work with, no square roots here. G of x, when you point that out, she says, Professor, it's this. It's x plus 1 over x subtract 2. And of course, I have f out front of that. And we know what that now means. Maybe I'll be patient. It says now go to your f function, and let's put that blue in there. Let me use my colors here. Now f function's up here. So if I go to it and replace, do not let me make a mistake. Use my colors here. X plus 1 over x minus 2 goes in. Right here. Plus 1 over x subtract 1 now becomes this. When I do my replacing, let's see if you guys will agree. Does it look like that? And I place the blue into the black. You guys agree with that? Does it look like that? Now, why would Ramsey bring in that? Which means now I will simplify this. Okay, now this is where I need some big time help. You guys may have some fractions on this exam tonight. It might be a little practice, a little good practice to review something here. Does anyone have an idea of what should I do to clean this up? Let's look at the numerator first. What's the issue up there? I want to put something together. What is it? By the way, guys, this is like 2 over 1. I think we eventually need to use
Could we make it 2x plus 2 over x minus 2?
Hang on now, I'm making 2x plus 2, I love that. Over x minus 2, absolutely. Then we're going to do that plus 1. Shame on you. No, not time. What are you going to do? You're going to combine with the common denominator. Which means you're going to write that 1 as, real quickly and be clever about it, as x subtract 2 over x subtract 2. That's still 1. And now those two have the same, denominator? So if I put those together, let me get that top part out of the way, numerator. Guys, add them up, I see 3x, oh, it's just 3x, the 2's cancel. These. You got 3x over that common denominator of that. That's the top done. Now let's jump down to the bottom here. Can someone suggest what should I do down here to simplify it?
X plus 1 minus x plus.
Okay, should I write, how about that 1 on the end? Do I need a common denominator again? Should I write that as x subtract 2 and x subtract 2 or not? Was it? Okay, they both now have the same denominator, guys. Now hang on, let's see what's going to happen. Be very careful on this one. If I put these two together, my goodness, let me bring it over here. X plus 1 over x minus 2. This bothers me. I got a subtraction sign. X minus 2 over x minus 2. I like to put them all over x minus 2, common denominator, down there. Anyone tell me, and be very, 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 very careful, what would that be all together on top? Well, the x's will cancel. I think it's 3. X's will definitely cancel. Is this 1 subtract a negative 2? Does that turn into a positive? Is it true? So it's 1 plus 2. Do I get a 3? I got a 3 down here. Yes or no? Now, can anyone tell me what's the answer? It's X. It's X. And if you don't see why you can do this, it's 3x over x minus 2 is being divided by, this is what means this. Some students will not have to go through all this, but this is what it means, 3x over x minus 2 times, flip this over. That's what it means. Which means these cancel, and yet all that work answers X. That's why I brought that in. Why can someone in class say, Professor, the answer is X? Why didn't you guys tell me before I did all this? Look at all this business. All this business. Why did someone say, Professor, it's X? The answer is X. You guys agree it is X? The composite is X. Yeah.
Would the domain be all real numbers?
There we go now. Beautiful. Did I ask for the domain on this one? Okay, here we go. Domain on this string. No. I. See where you are. If you got an answer of X, you'd say, Professor, that's open. I don't see any restriction at all. It's just X.
But there is the number.
Yeah, there's some restrictions. So to get there, I placed what here? I placed G. What, down here, was there a restriction on G? Yeah, X cannot be what? 2. And if I need it, up here, X cannot be 1. Now, let's see, what am I using here? Which one am I using here, guys? I could not have done this, if this is undefined inside here, I could not have done all this work. So X plus 1 over X minus 2, I better take note. Did they say out here, do not let X be 2? So I gotta make sure I put that right here to show I could not have done the problem if I had not recognized that. And you could place that in internal notation if you wish. Yes or no? Ooh. Ah.
That's why I'm including 1.
Okay, now, are we going to include 1? It says X cannot be 1. I'm going to throw maybe X cannot be a 1. We'll see. Okay, let's try this. Here we go. Let me try first and show you with the 2 there. Suppose you were asked to find F circle G, good question, of 2. We've already said, Professor, I don't think 2 is going to work. This means this. Go to my G function, put a 2 in, immediately it's undefined. Undefined. Now can I use 1? Which means this. Can I put a 1 in down here? Is it valid? If I put a 1 in down here, what's that? 2 over what? Negative 1 is a negative 2? Let's see if I can finish it up. Now, is it okay to take negative 2 back up here and not run into an issue? Could I actually replace X by negative 2 and actually get an answer and not run into an issue? So 1 is okay. Mr. Park, June, you guys see any other restrictions on this one besides X can't be 2? A little tricky. Yeah, June, go for it.
So, since what's inside the x cannot be 1, and we put g of x inside the f, so I think g of x should not be equal to 1.
Oh, I got you now. She's saying, Professor, this. Look at this, guys. She's saying, this right here you placed inside F. The blue. And the blue had a restriction on it. I think, where was it? X cannot be what? 2. She's saying, Professor, at the same time, you've already said F, the restriction was you can't let that be a 1. Is that true? X cannot be equal to a 1. So she's telling me, Jen, I'm trying to follow what you're saying here. Hang on. G of X, and we've got F. F has a restriction, cannot be equal to a 1. The domain cannot be equal to a 1. So you tell me this right here cannot be a 1. I think you're telling me that.
Yeah.
That's true, guys? So she's thinking a little differently here. Now, what can I do here? If I try to solve it, June, what would I do to solve this and see if I can pick up any other restrictions?
I mean, I know that the numerator and the denominator is the same when it equals to 1, but you can multiply both sides by x minus 2.
Now, if I do, watch what happens. I got you exactly. I know exactly what you're saying. Even if I do that, will the x's cancel? Will these x's right here cancel? Now I have no x remaining. Woo! I followed exactly your logic. Exactly. Guys, I think the only number out there that you can't use on this particular composite is, what was it? In fact, Arena, I'm so glad you said, Professor, I don't think you use a 1. But we tried 1 worked. Right? So if there's another one out there that you think will not work, we try it and see, but it looks like at this point, x can't be 2. Wow, wow, wow. What's the last one on that? There's one more. Geez, I want to move on here and do something else. What's the next one?
G of F.
With the same functions.
Yeah.
Okay. I'm going to sort of repeat myself. If I do it the other direction, he says they want us to do, not this professor, they want you to do G circle F and come up with some restrictions if possible. Would you like to see that one also worked out since it is on the handout? Please tell me, is that the last of the last? Okay, here we go. I have a strange feeling what's going to happen. I've already found the, she asked me to find this one, F circle G. Now she says, Professor, to finish that worksheet up, you're asking to find this one. Tell me why Ramsey may have placed this on the handout. Tell me what might happen here. We did the F circle G and got an answer of what, X? Now they're asking to do it backwards, G circle F. What do you think if I have it? I bet we get X again. I bet we get X again, even in the other direction. Let's see if we do that. Here we go. This means G of F of X. G of F of X in this case was, I guess, erase it here. Was that, help me out here? What was F of X? Erase it. 2x plus 1.
Over x minus 1.
X minus 1, thank you. That. That says, please take that to the G function. I will. Do a replacement in the G function. The G function, I guess, did I erase it also? Or is it that? That was the G function. So go to the G function, if you're replacing, and please tell me it might look like this. Get all this written up correctly. Guys, that's the way it looks when you go to the G function. And then clean this up. I bet you get X again. I'm gonna write this as X subtract 1 over X subtract 1. Let me use the common denominator. I'm putting it on the side here, guys. All this is over X subtract 1. I think you're gonna end up with 3X. You guys will follow me? Do I? Down here, the 2, what would be a nice way to write 2 and then use that common denominator of X minus 1? Help me out. What do these two put together with the common denominator of X minus 1 look like? 2x plus 1, I'm hearing, and minus what? Minus 2x plus 2?
Yeah.
All over x minus 1. So you just combine these two with the common denominator of x minus 1 for me. Did I leave my x off? I think you said negative 2x. Marina? Okay. 2x is canceled? These cancel? Do I end up with 3x over 3 again? Oh my goodness, I got x again. Did I? I did it quickly. Did I get x again? That's the other composite. So guys, at this point, we're saying for this, Karina, We're saying when we did it this way, Professor, you get the same answer as when you do it this way.
Domain is different.
Oh, hang on. Right now, right? Now, she said, okay, now how about the domain on this last one, Professor? The domain of G circle F. Here goes. Here goes, here goes, here goes. G circle F. Where was F? F was, my goodness, I did not write down. Yeah, it was what,
Yeah,
2x plus 1 over
that's
x minus 1? Was I actually placing that, was I actually placing that into the function? Was there a restriction on this? X cannot be what number? 1. That true? The way the composites turn around? The last one I just did, I think, the domain was x cannot be what, 2? Now it's x cannot be 1. Just the way it's turned around. Oh my goodness. Now, I'm moving on. Surely tell me, was that the last of 4.1? So we're gonna move into 4.2 here shortly. But can anyone tell me, maybe with some knowledge of yours in math, why, when I brought this in on the end, what is this telling me? What is all these results of, Professor, I got X, I got X, I got X. Anyone tell me where this is leading me? In math. When your composite comes out to be nothing but X. And I did it in both directions. It came out to be X in both directions. There's something special. I need a key word. I don't know whether you remember or not. There's a key word when two functions do that to one another. Form the composite and you get merely X on both composites. There's something special between those two functions.
Are they inverse functions?
They are inverse functions. One function is the inverse of the other. If that happens, and it happened here. Arena, class, give me a race. And we'll jump into, should be 4.2, I guess. Gone. I'll just mention right quickly. F of X, she gave me as, I do not want to copy this down incorrectly here. Karina, what was it, 2x plus 1 over what?
X minus 1.
X minus 1. And the g of x was?
X plus 1
X plus 1,
over
x minus 2. We're saying those two functions are inverses of one another. Here's the issue. If I should ask the student, what's the inverse of, I'm say teaching an arithmetic class. And I look at a student saying in arithmetic, I say, what's the inverse of 4? More than likely you would say -4. Is that true? If I say, what's the inverse of a -60? PK would quickly say +60. If I say, what's the inverse of 3/4? You might say -3/4. Then all of a sudden I hear a student say, whoa, Professor, you said 3/4 and -3/4 are inverses. Why not 3/4 and 4/3? What's the difference? If I just use the inverse general term, and I say, what's the inverse of 3/4? You say -3/4. And all of a sudden another student said, wait, Professor, I thought the inverse of 3/4 was you flip it over from the reciprocal 4/3. Is that also an inverse? I can't use both. That's what's happening here. So guys, we've got to accept on inverse. You do not have an inverse unless you do that check with those composites. The composite's got to give you an X in both directions here. Okay, that's the only way I can accept it. I thought I saw a hand going up. Was there a
I was
hand?
gonna ask if the inverses like these would look similar on a graph.
Well, tell me again.
Like, would there be a visual relationship if we were to graph both of these?
Thank you. Hang on a second. Just a second. Back to what I'm moving into here, then I'm gonna get into what that 4.2 is all about. Here we go. Yesterday's lesson, and you know the way I teach. I try to connect things. Yesterday's lesson, I think we were doing rational functions. Were we? Can anyone look at this? I'm not gonna grab this thing today. This is a rational function. For an example, can anyone tell me right quickly, where the vertical asymptote would be located if I should graph this first function? Based on what we did yesterday, Andrew was reading from the handout. Where's the vertical asymptote located if I were to graph the f function? Anyone? 1. I think you said that on the handout, you said what? The denominator equal to 0 and solve it? And if I set that denominator equal to 0 and solve it, I get 1. So my vertical asymptote is 1. Now, can someone give me a crazy, crazy guess? Where's the horizontal of the second? 1. So the vertical on one turns into the horizontal of the other. Only if they're what? Inverses. We'll try another one here right quickly. The first one, can anyone tell me right quickly, and be careful, I've got some clever students in here. Can anyone tell me, in fact, I better help you out here. Let's try to find the x-intercept. Watch what happens here if I get into my lesson. If I try to find the x-intercept of the first one, you say, well, Professor, I know how to find an x-intercept. I may have to find one tonight on the test. You said this equal to 0, don't you? That's where you find an x-intercept. You set the function equal to 0, right? If I do a little multiplication, you can say, Professor, it looks like this. Just multiply both sides by x minus 1, get rid of that x minus 1. Solve for x, please tell me, is it negative 1/2?
Yes.
I'm gonna write like this, you know me, I like the word pairs for intercepts. Now, can someone tell me now, get ready, where's the y-intercept on my g function? And find y-intercept, you find what? G of
Minus 1.
0. And hold on, up there. 0 plus 1 over what? 0 subtract 2, what is it? And I'll write this as a ordered pair. This is a y-intercept, so it's right like this. What am I trying to show? What did I just show? That when I ask you to find the x-intercept on this one, we found it. It's negative 1/2 on the f. You should graph it. The x-intercept on the g, the y-intercept on the g came out to be what? Negative 1/2. Did it come out to be the same number? But in one case you're doing x-intercept, the other case you're doing what? Y-intercept. That's like an inverse. So what's making that happen? These two functions are inverses of one another. So what happens on one, the opposite happens on the other. That happens only for inverse functions. So these are rational functions here, and are inverses of one another. Wow. Okay. I gotta watch my time here, to be carried away here. Marina, depending upon you today. You don't mind, do you? Okay. Tell me what the next part starts out with. Uh-oh. Hang on. A definition. And what's the definition?
Let f be a one-to-one function with domain H.
Okay, now wait. Let a function be 1-to-1. Now, we'll stop you right there for a while. Well, what other functions are out there? She said, Professor, make sure this one's 1-to-1. What that means? We've got with all kinds of functions. So right now at this point, all my students, if I say, here's a function, I'll make up one real quickly. That's a function. Is that this? Here's a function. Is that this? So make sure now that this function for this next part coming up is a 1-to-1 function. Does anyone have an idea? Because I'm going to show you. What on earth do they mean for me to look at to see is this function 1-to-1? I'll tell you ahead of time, one of these is 1-to-1 and the other one's not. Do you want to have an idea?
Does it have to do with the exponent?
Not necessarily. I see what you're looking at, not necessarily. First, which one do you think is of the two? They're both functions. But now for today's lesson, which one might I classify as one-to-one, Professor, and the other one's not one-to-one? And what on earth is one-to-one? Which one do you think it is? Yes.
Is it because the exponent could be like plus or minus, while the other one, like, is it line?
Oh, no, I think,
Like
same
quadratic?
thing you're thinking. Very close what I want, yes, very close. So, again, tell me though, is it this linear function, or is it this quadratic? Which one do you think is one-to-one?
The linear?
You think this one is? And the quadratic is a function, but not a one-to-one function. Why? And I think I heard a description of that, something about two answers coming out or something, right?
Yeah, because with the quadratic, you could get two x values, like, it could be or two y values.
Now, okay, you said something about those two values. Hang on just 1 second. Hang on. Before we take a break here. Let me start you out with something simple, then we'll see what's going on here. I'm going to do this in sets. Set A. I'll make this very elementary to get a conclusion here. I brought in a set A, and I placed these ordered pairs for a reason. -1, 2, 0, 3, 3, 5. Make sure I got the copy down correctly. And I threw in one more for presentation here. That's not 3, 5, it's 2, 5. 2, 5. And then it jumps over to 9, 12. Okay, let's step back and look at it, it's looking good. It represents a function. It's a function. Now the question is it a one-to-one? I have not described myself what a one-to-one function is yet. Is it a one-to-one function? What do you think I'm looking at here to see whether it's one-to-one or not? Go for it.
If you do one, like you add 1 to the x, and then y goes up by 1 as well.
Oh, whoa, you know what you're looking now, let's see what you're saying. Andrew, you're looking for a name, an equation for this. You're seeing a relationship going on. I did throw a relationship. Let's get that relationship out of the way. Name the function for the class, f of x or y. Give me a formula. What did I have in mind when I wrote those numbers down?
Well,
And it's got to work for each ordered pair.
no.
Andrew, he was describing for me. I had something in mind as I wrote -1 was 2. I didn't just randomly put in there. 0 with 3. I had something in mind. 2 with 5. 9 was 12. I hope I didn't make a mistake in writing. I had something in mind as I wrote those. I didn't just randomly choose them. What was it?
Is it
X plus 3.
y? Oh.
X plus 3.
Is it 3 halves?
Never heard it. Is it x plus 3? Are you just adding 3 to the x?
Oh, yeah.
All the way across to get the y. Nice little simple linear function. Is that true? Hang on. Now as I examine closer, I have -1 paired up with 2. Do I have -1 paired up with anything else? No. I have 0 paired up with 3. Do I have 0 paired up with anything else? I'm making a one-to-one argument here. 2 is paired up with 5. I do not have 2 paired up with anything else. And finally, I paired 9 up with 12 and did not do anything else. That's a one-to-one function. And actually, we have the name for it. So in essence, I see sort of now what one-to-one function has to do. Now, here's another one here before we close down. Really got to close down here shortly. Set B looks like this. And this time I threw in these numbers, and I think we'll take a break after I write down these. -1, 1. -2, 4. I threw in 2, 4. Whew. Now first, let's check and see, is it a function first? And most students will say, Professor, for a function, for it to be a function, the x's must not repeat. -1, -2, 0, 2, I do not have an x repeat. That's all it takes to check for a function. So it is a function. Is it 1-to-1? Okay, let's see what happens here, guys. I have -2 paired up with 4, for an example. Do I have something else paired up with 4?
Yeah.
It's not 1-to-1. It's not 1-to-1. Now, by the way, can anyone look at those numbers I placed right quickly and tell me what function did I have in mind? Like Andrew, I think, gave me this one, x plus 3. Does anyone see what this one is representing? Thank you. X squared. You square the x, you get the y, all the way across. Except this one is a not 1-to-1. The first one was. We see the difference why? Why one is considered 1-to-1, the other is not 1-to-1? That's what we're talking about here. Now, I don't know, did I have some items in there? I'm not going to do it right now. Did I have more in this section to do? Yeah, we're not going to do it right now. Ooh. We're going to take a break here shortly. June, Mr. Park, I'm going to give him at least an hour and a half for this test, at least. Maybe a little bit longer. Oh my goodness, I'm trying to think of a good time that we should. They're going to have a 15-minute break now. I'm thinking about, okay, it's 5 till, so maybe 10 after, come back. So that would be 10 after 2. Oh, yeah, whoa, we're cutting time short, aren't we? Ooh, whoa. You guys want to take a 10-minute break today? Don't tell the college I didn't get us. But you're supposed to take a 15. You need your 15-minute break. Do we need to? Yeah, we're going to take a 15-minute break. Take your 15-minute break. I'll see you at 2:10.